Welcome to You Can Do It Maths. Today we're doing the February-March 2021 paper 42, extended, the long one. Let's have fun. Question 1. We see here 3 workers, a painter, a plumber, electrician, and they all get pretty decent pay. Not a bad profession to have any of those. It says that these are the rates charged by these people who do some work for Mr. Sharma. The painter works for 7 hours. Calculate the amount Mr. Sharma pays the painter. This is straightforward. So if you pay him $35 per hour and it's 7 hours, it's 35 times 7. Sweet, 245. No problems there. Okay. Question B says Mr. Sharma pays the plumber $252. Calculate how many hours the plumber worked. Okay, so be careful. This is not that straightforward because there's this fixed charge of $40, which means the plumber gets paid $40 and then he starts to do his work. So first we need to subtract that $40. So it's 252 subtract by 40. What that is $212. So now this is where he started paying the plumber. So if we want to know how many hours, we need to divide the rate per hour into that 212. So it's 212 divided by 26.5, and that's 8 hours. Okay. Question C. Mrs. Sharma pays the electrician $224. Calculate how many hours the electrician works. So here it gets a little bit more complicated. $48 per hour for the first 2 hours. So let's just think about that. Yeah. So the first 2 hours, let's write that down. First 2 hours was $48 per hour. So that's 48 times 2, which is $96 he paid for the first 2 hours. From then on, he was paid 32 hours. So first we need to subtract that amount, 96 from 224. Okay, it's 128. And from here on, he was charged $32. So to get the next amount of hours, we need to divide it by 32. So 128 divided by 32, that's another 4 hours worth of work. So in total, the 2 hours paid it for the first 2 hours plus the next 4 hours, that will give us 6 hours. Okay, now write down the ratio of the amount Mr. Sharma pays the painter, the plumber, and the electrician. Give your answer in its lowest term. So let's have a look. First of all, how much did he pay the painter? That we got in question A. He paid the painter $245. Okay, it needs to be in the right order. So painter first. Then the plumber, he paid the plumber $252. And lastly, the electrician, $224. Okay, and that is the ratio. Right, the next step is to find a common factor. Okay, and it's not as easy as it looks because 2 is not a common factor. We can't divide 5 by 2. Okay, maybe 3. Check 3. Can we divide 245 by 3? No, that gives us 81.6. It's not going to be 4 because there's no number that ends in a 5 that's in a 4 times table. It's not going to be 5 because this ends in 2 and that ends in 4. That will be in the 5 times table. 6, we can try 245 divided by 6. Again, that gives us 40.83. Doesn't work. What about 7? Let's try 7. 245 divided by 7 is 35. 252 divided by 7 is 36. And 224 divided by 7 is 32. Okay. So it's kind of trial and error I did there, working it up from the lowest from 2. And when I got to 7, I found the common factor. Is there anything else? No, there's only one difference between 35 and 36. So that must be the lowest terms. Question 2 is all about transformations. In question 2a, number 1, they ask us to describe fully the single transformation that maps triangle A onto B. Okay, get tracing paper. If you don't have tracing paper in the exam, ask for it. I have to give it for you. And we trace shape A as nicely as possible. Right. So, what can this be? Right. It's not an enlargement because it doesn't change shape, size. It's not a translation because it is not in the same orientation. It is not a reflection because it's not symmetrical, hasn't flipped over. So it can only be a rotation. And that's the first thing you need to write down, the type of transformation, because that will be your first mark. It is a rotation. Okay, 1 mark. Next, we remember what is rotation is about. There is the direction and the center of rotation. Okay, finding the center can be a little complicated sometimes, and there's a method to find this with a compass. But on this level, best is just to try trial and error. So let's see. Let's try the center first, 0, 0. Okay? You can see we're a bit too low and a bit too far to the right. So we're going to move up a little bit and a bit to the left. Let's have a look. All right, I seem to be on the right line on the x-axis. I just need to move up a little bit. So let's move up 2 squares. No, I need to move to the left. Let's move to the left. Let's try 1 square. Okay, a bit too high, a bit too far to the left. Let's try over there. Must be very close, somewhere around here. Let's try over there. Bam, got it. Okay, so trial and error by simply adjusting your center a little bit, we can find it, and it's right over there. Okay, so the center of rotation is the point -3, 2. That's another mark. And then, of course, we need to do the direction and the angle. As we did only a quarter turn, that will be 90 degrees. And we're going in this direction, which is anti-clockwise. So we write 90 degrees anti-clockwise. Of course, 270 degrees clockwise will also be correct. Next one, from triangle A to triangle C. Okay, and this time it changes size. So it can only be an enlargement. Let's write that down. First mark, enlargement. Now I got 1 mark. Right. Now, as you can see, it's also flipped over. So this must be a negative enlargement. Let me show you how we're going to know this, right? We're going to connect each corner here with the corresponding corner there. Let's start with a 90-degree angle first. That's the easiest one. I'm going to connect those two like this. Okay. Right, then there is the bigger of the 2 angles connected to the transformation angle there. And lastly, there's the shorter of the remainder, the smaller of the remainder angles, and we connect that. And if you do this right, you'll immediately notice one very clear thing. All the lines converge over there at our center of enlargement. Okay, so that will be the next mark. The center of enlargement in this case was -2, -1. Okay, now for the scale factor. Okay, scale factor here, the shape has gotten smaller. So that means if it's getting smaller, it is not negative, it's a fraction. Let's look at the base of the triangle. It's 1, 2, 3, 4, 5 squares wide. No, I can't count. 4 squares wide, and the base here is 2 squares high. The height here is 1, 2, 3, 4, 5, 6, 7, 8. The height here 1, 2, 3, 4. So it's gotten half in size. So that means the scale factor is a half. But that's not all of it. It is also on the opposite side of the center of enlargement, which means it's got inverted. That is why it's negative. It's not negative because it's smaller. It's negative because the enlargement is on the opposite side of the center of enlargement. Excellent. Now, question 2b, draw the image of triangle A after translation by the vector -5, -10. Okay, now remember, with the vector, the top number tells us if we're going left or right, negative, so we're going to the left. The bottom number tells us about how much to go up and down, and it's negative, so we're going down. So let's grab the tracing paper again. So first of all, -5 means we move 5 squares to the left. So it's 1, 2, 3, 4, 5. -10, we drop down 10 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Check carefully the corners, because the shape needs to stay exactly the same. And then with a ruler and a pencil, clearly draw the new shape. Question C. Draw the image of a triangle after a reflection in the line y equals 4. Common mistake is we're going to x equals 4, right? Y equals 4. On the y-axis, the mirror line goes through 4. So let's make that clear. Okay, now the reflection means we need to flip it over. In this line, it's going to be upside down and it's to be 1 square away from the middle line. So this right angle here, 1 square to the middle line, so we go 1 square down. This angle here, again, same. And this point up here is 1, 2, 3, 4, 5, 6, 7, 8, 9 squares to the middle line. So we count another 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right over there. Ruler and pencil. Practice to be an architect one day. Perfection. And you've done it. Question 3a. Angles. The diagram shows 2 straight lines intersecting 2 parallel lines. The moment you read parallel lines, you need to think immediately. Corresponding angles, or the old F angles, alternate angles, or the old Z angles, or interior angles. So these are the things we're going to look for. Okay, to find A though, got nothing to do with the parallel lines. This is basic opposite, vertically opposite angles. So A is 126. Right, let's slot that in there as well. It always helps. Right, question B. There's more than one way to get here. But again, like I said, we can do corresponding angles. So it means this angle next to B is 126. Or alternate angles. Okay, either way, that gives us 2 angles on a straight line, which means to get B, we need to do 180 minus 126, which will give us 53. Okay, 54, of course. 53, 54, don't be silly. Right, so B is 54. Last one, C. That's clearly interior angles, which adds up to 180. So again, we do 180 minus 63, and this time it will give us 117. Get it right. Question B. Points R and S lie on a circle with diameter PQ. Okay, diameter there. Immediately what comes to mind is possible radiuses and the circle theorem, which states that angles in a semicircle is 90 degrees. Okay, meaning that angle formed at the top from a diameter is 90 degrees, and that's what we have here. Got the diameter here, so it means this angle at R, or PRQ, is 90 degrees. Okay, remember what I said, deal with every piece of information one at a time. So we have now sorted that piece of first information. That is what it gives us. RQ is parallel to PS. Again, we're going to be looking at corresponding alternate or interior angles. Find the value of X, giving a geometrical reason for each stage of your working. Okay, so as we see, we already got that angle is 90 degrees. We need to state it and give a reason why we said that. Okay, it's not just enough this time to mark it. So we're going to write angle PRQ. So PRQ equals 90 degrees. And the reason for this is angle in a semicircle equals 90 degrees. I don't think you have to write that, but to be thorough, let's put it in. Okay. So once we have that, we've got angles in a triangle. Will give us this angle over here. Okay, so I'm going to be writing angle PQR equals 180 degrees minus the other two angles in that triangle, which would give us 32 degrees. Making good progress. Okay, so we got our angles in the triangle. How have we used this piece of information yet? The one that talks about the parallel lines? No, we haven't. So it means somehow we need to use that. And we're looking at these. This is the one we're going to use. If you look here, we got a clear Z angle, which means X is 32 degrees. So we can write X equals, well, angle PQR to be thorough, which equals 32 degrees. And the reason for this would be not Z angles, please don't write Z angles, alternate angles. Okay. I left one out. Now we want things to be correct. So just in case, I never said why that's 32. It's because angles in a triangle equals 180 degrees. Definitely we get our full marks there. Question 3C, another circle theorem question. Right, we got 4 points of a quadrilateral. 3 are on the circumference of the circle and 1 is at the center. So don't confuse this with a cyclic quadrilateral. It is not, since that point there in the middle is not on the circumference of the circle. We cannot use the cyclic quadrilateral theorem. But what we can use, even though it doesn't look like it, is the angle at the center of a circle is twice the angle at the circumference. Meaning this angle here, the reflex OAC angle, is twice the angle on circumference ABC. So we need to start, first of all, working out the reflex angles. So that's 360 minus 142, which gives us 218 degrees. So this angle here, 280 degrees. And then this angle is twice the angle of circumference. So y is 280 divided by 2, which gives us 109 degrees. Question 4 A shop gives each of 1,000 people a voucher. 28 people use their voucher. We can see this as a fraction. 28 out of 1,000 people is using a voucher. The shop now gives each of 16,500 people a voucher. So we have a similar equivalent fraction. Calculate how many of these 16,500 people are expected to use their voucher. So this is what we want to know up there. So with equivalent fractions, we need to see how do we get from 1,000 to 16,500. If you're not sure how to do that, you do the reverse. 16,500 divided by 1,000, which is 16.5. So it means we need to multiply this by 16.5. And with equivalent fractions, we do the same at the top and the bottom. So we do 28 times 16.5, and we got the answer 462. Right, question B. In a class activity, all the 15 students wear hats. 17 students wear red hat, 6 students wear green hats, 2 students wear white hats. One of these students are picked at random. Find the probability that this student wears a red hat. There's 7 students out of 15 wearing a red hat. Straightforward. In part 2, 2 of the 15 students are picked at random. Show that the probability that these 2 students wear hats of the same color is 37 over 105. I kind of give you the answer there. So let's think about it. 2 of the 15 students are picked at random, the same color. So let's start with red. Okay, the probability of a student wearing a red hat is picked is 7 out of 15. We then have to pick another student. Again, we're not going to pick the same one. So there will now be 6 students left out of 14 wearing a red hat. Okay, and this is here where we need to remember the and the or rule. Okay, the and rule stipulates that we multiply. So for this to be true, this 7 out of 15 and 6 out of 14 needs to happen. So we're going to multiply. Okay, the next will be 2 students wearing green hats. So the probability of wearing a green hat is 6 out of 15. Picking another student with a green hat then will be 5. There's only 5 left with green hats, and there's only 14 students left. So this and that has to happen. This was for a green hat. Last one was the white hats. So having 2 students wearing white hats, there are 2 students wearing white hats out of 15. If we pick one, there'll only be 1 student out of 14 left wearing white hat. Okay, that was 3 possible things can happen. Okay, next we're looking at the OR rule. When we have the OR rule, we add. So one of these things need to happen. We have 2 students wearing a red hat, or we have 2 students wearing a green hat, or we have 2 students wearing a white hat. So we need to add those together. Right, so let's do that. Check if we got the right answer. Type it in exactly like we wrote it. And if we type it in correctly, we get the right answer, 37 over 105, and we know we got it right. Question 4b, number 3. This question has the potential to become a little bit confusing. To avoid that, I'm going to draw a tree diagram. It might be time consuming, but it will have things a lot more clear. So let's think. There are 3 events happening here. We are picking a student 3 times. And we can simplify that by simply going with red or not red. So we have a student being picked wearing a red hat or not a red hat. After that, we're going to have another event, And we might pick a student got a red hat or one that's not. And down here, the same, pick a red hat or not. That's picking 2 students. And then the last event, again, pick a student with a red hat or not a red hat, a red hat or not, red or not, and red or not. Now let's put in these probabilities. We stay focused, we can get this right. Picking a student with a red hat is 7 out of 15. That means picking a student with not a red hat would be 8 out of 15, since it needs to add up to 1, 15 out of 15. Okay, again, if we picked one student with a red hat already, there will be 6 students left with red hats and 14 of them in total. If we pick another student then with a red hat, there'll be 5 students left with red hat and 13 students in total. Okay, over here, it needs to add up to 14 out of 14, which is 1. That means we will have 8 out of 14. Okay, and over here, we picked a student, there's 5 out of 13. That means this have to add up to 13 out of 13, so this is 8 out of 13. Okay. Now, if we picked a student with a red hat and not a red hat, and then again a red hat, we already picked one with a red hat, so that means we got 6 out of 13 left. Means students no red hat would be 8. No, that adds up to 14. Would be 7 out of 13. Okay. Let's go down here. We picked a student with not a red hat, 8 out of 15. Then picking a student with a red hat, there are 14 students left, and 7 of them still has their red hats. Then picking another one with a red hat means now we got 6 left out of 13. Okay, so if that's 7 out of 14, this is 7 out of 14. Then picking another student without a red hat, that means we got 6 out of 13 left. And the last one here, we follow not red, which means all the students with the red hats are still there. And there's 13 students left. All right, now we just need to pick the same route. There are 2 ways to attempt this. We can follow all the routes where there's 2 reds, or at least 2 reds. Or you can do the opposite, pick all the routes in this tree diagram that is less than 2 red people picked. Okay, but I'm going to go with the most obvious. Okay, we're looking to pick any routes in these tree diagrams where we have at least 2 with red hats. So let's go start from the top. If I pick a student with a red hat, and again with a red hat, and again with a red hat, that is at least 2 students with red hats. So that's something we want to do. So that and that and that has to happen. So this is the AND rule, which means we're going to have to multiply those values together. Okay, let's do that quickly. This is a time-consuming question. Which gives us 1 out of 13. Okay, of course, we can do the same route. We can pick a student with a red hat, and then not a red hat. So this still has at least 2. So this will be 7 out of 15 times 6 out of 14 times 8 out of 13. Okay. We can speed things up by simply changing our previous question. That 5 is now an 8. and we get 8 out of 65. Okay, next one. We pick somebody with a red hat, then somebody not with a red hat, and then somebody red hat again. Again, we've got at least 2, so we need to follow this route. That's 7 out of 15 times 8 out of 14 times 6 out of 13. Okay, now we can see we've got the same calculation as the one above. 15 times 14 times 13 and 7 times 8 times 6, just like we had 7 times 6 times 8. So that will give us the same answer as before. The next route, red, not red, not red. This is not a route we're going to calculate. Okay, since there is not at least 2. Then we go. Somebody with not a red hat, and then a red, and then a red. Yes, we have at least 2 red, so we need to work this out. So that is 8 out of 15 times 7 out of 14 times 6 out of 13. Again, we got 8 times 7 times 6. It's the same calculation as before, so that's 8 out of 65. Okay, next route, somebody not a red hat, then a red and not. This is not at least 2. Again, not red. There's not at least 2. There's not at least 2. So we're getting close to the final answer. So we can speed up the last calculation. We now need to do 1 over 13 plus 8 out of 65, 8 out of 65, 8 out of 65. Quicker way to do that is to multiply 8 over 65 by 3. So let's do that and add up the 1/13th, and we have a final answer, which is correct. 29 out of 65. Question 5. Triangles. The moment we see triangles, we know we're going to use trigonometry. Now, with right angle triangles, it is Pythagoras or SOHCAHTOA. But as we can see here there is no right angle triangles, so we need to go with the sine or the cosine rule. Sine rule, what we're usually looking at is 2 angles and a side, or 2 sides and an angle, and we're looking at opposites. We're looking at angles and finding the opposite sides. That's what we're going to use. The cosine rule is we're either working with just all the sides, we want to find an angle, or we got 2 sides and an angle, we want to find the third side. In question A, calculate angle ADB. ADB will be this angle over here, which we want to calculate. Okay, what do we have in this triangle? We've got 3 sides. Okay, meaning we are going to use the cosine rule, which is the following. A squared equals B squared plus C squared minus 2BC cos A. Okay, working with 3 sides means we're going to have A, B, and C, and the angle is what we want to find out. And we can use a formula in this format and then rearrange it after we substitute in the values, or we can use the alternate method, alternate form of the cosine formula, if you like to memorize it, which is very good. Okay, which is cos A equals B squared plus C squared minus A squared, as you can see, move that across, over 2BC. This is the better version to use in this case. Okay. We got A, D, and B here. We can label this triangle ourselves to make it easier, right? We make the angle that we want to know, A. That means the opposite side to A will be our lowercase a. we can keep the b as a b over here, and that makes the opposite side a lowercase. And we can relabel this AC for our formula, which makes this 9.7 the lowercase c. If we swap the b and the c around here, in this case it doesn't matter, as long as we label A, the angle we want to know, and the opposite side, the lowercase a. So here we go. Let's substitute in the value. So cos A is what we want to know, but in our case, it's actually angle ADB equals B squared, so that's the 8.6 squared, plus C squared, which we got 9.7. If we swap these two around, it doesn't matter. What is important is that the lowercase a is the 4.4 squared divided by 2, and again that b and c values in any order. Okay, what we're going to type into our calculator is to find the angle ADB, we need to move the cos across, so that will be negative cos to the power of -1. So let's see what it looks on the calculator. We're going to start by pressing shift, cos to the power of -1. We want to do a fraction, 8.6 squared plus 9.7 squared minus 4.4 squared. Push the down arrow, 2 times 8.6 times 9.7, side arrow, close the brackets, and there we go. We have the answer 26.973, etc., which we want to write to three significant figures, which would be 26.0. Question 5c. So as explained before, we're working with triangles. If it's right angle triangles, we use Pythagoras or Quadrature. If it's not a right angle triangle, we use sine or the cosine rule. So for question B, calculate DC. DC is this side over here. We have the opposite angle. And the moment we work with opposite sides and angles like that, we know we're going to use this sine rule. So let's write that down. Sine rule is, let's think about that, A over sin A equals B over sin B equals C over sin C, but we usually just use two of those. And we can write it the other way around. We can put the sine A and the sine B at the top and the A and the B at the bottom. But the reason I put this A at the top is because we want to work out a side, so that makes it easier to put the value at the top. So the side we want to work out is side DC. So we're going to write that down, DC. So note, in this case, I've made the side I want to know the lowercase a. So opposite to that, the angle 65 will be the angle I'm going to work as A. So that will be sine 65 equals. All right, we need another side and another angle. The only other side we have here is 9.7. So in this case, I'm going to make that my lowercase b. Forget about the values they put there. Okay, so that means I've got another 9.7 here, and the side, the angle opposite to that side is going to be our uppercase B, but we don't have that angle. Luckily, we can work it out. This is basic angles in a triangle. 180 minus 65 and 42 will give us that third angle. So let's write that down. 180 minus 42 plus 65. Let's log that in. 73. 73 is the angle we need there. Okay, now it's very helpful that we've got the side we want at the top. So to work that out, we just multiply the sin 65 on the other side. So my final calculation will be 9.7 times sin 65 divided by sin 73. Let's hammer that into the calculator. Now we get 9.19, etc. Okay, rounded to three significant figures, 9.19. Question 5C. Calculate the shortest distance from C to BD. Going back up to our triangles, the shortest distance from C to BD. So it's the shortest from here to the line, which is 9.7 centimeter. And what you need to recognize here, that this refers to a perpendicular line. So the shortest distance going from C to this line can only be a right angle forms a right angle triangle. It's a perpendicular line. Then we recognize here that we're going to have to use Pythagoras or SOHCAHTOA. Now we're working here with this 42 degrees angle, and the hypotenuse we just worked out in the previous question is 9.19. Working with angles and sides means we're going to use SOHCAHTOA. Okay, so let's have a look. What do we have? We want to work out the distance from C to this line here. Let's call it X. Okay, in this triangle, it is the opposite side to the angle we have, and we're also going to use the hypotenuse. Okay, using the opposite and the hypotenuse means we're going to have to use the sine rule. So let's write that down. Okay, let's go back down here. So the sine rule is the angle we're using, which is 42, equals the opposite side. In this case, we've labeled it X, divided by the hypotenuse, which is 9.19. So we're going to have X divided by 9.19. Right. So to work out X, we multiply the 9.19 on the other side. So in our calculator, we're going to slot 9.19 sin 42, and that will give us X. Let's do that. 9.19 times sin 42, and there we go. We get X as 6.149, etc. Rounded to three significant figures, 6.15. Question 6a. What they give us here is a quadratic graph, and they give us the general form of the quadratic graph, and they want us to find the values of a and b. First thing, easy to find, is the value of a. The value of a is 4. The reason we know that is 4 is the y-intercept over there. And with any graph, the term that is only a single number, that will be the y-intercept. Let me show you a few more examples of this. We go on Desmos graphing. You look here, I've got a linear graph, y equals 2x plus 2. That plus 2 gives me the y-intercept, which is 0, 2. It works the same for a quadratic graph. I got y equals x squared plus 2x minus 2. See that minus 2 number by itself? That will give us the y-intercept there, minus 2. Works for all. In a quadratic graph, I got here y equals x cubed plus x squared minus 2x plus 4. That plus 4 gives me the y-intercept, 0, 4. So in our question, it is the same thing. Okay, my graph goes from 4 there. That meaning that gives us the y-intercept. We know this because if we set x to 0, we make x 0 in our equation here, we'll get y equals a plus b 0 squared. Now 0 squared is 0. 0 times b is 0. So that means y equals a. So wherever we cross the y-axis, that will be our a value. All right, next thing to do is to find the b value. Let's see what we have, right? We've got this equation, y equals, we now know 4 is equal to a plus bx squared. Okay, what other information do we have? We've got coordinates. Remember, these coordinates are x and y values. So we can substitute one of these coordinates into the equation. The first one is not going to work because if y is 4, that gives us 4. Bx is 0. 0 squared is 0 times b is 0. That gives us 4 equals 4. We know that. Doesn't give us the answer though. But if we substitute the second coordinate in there, we'll have y equals 1, 4 plus b, x equals 1 as well. 1 squared is 1. 1 times b is b. That gives us 1 equals 4 plus b. So b must be 1 minus 4. Gives us b equals -3. Question 6a, number 2. Write down the equation of the tangent to the graph at 0, 4. So 0, 4 is that turning point right there. And we can just imagine if we were to draw a tangent there, it will be a horizontal line like this, going through 4 on the y-axis. So the equation, this is very important, we need to write an equation which has an equal sign, is the line that goes through 4 on the y-axis. Y equals 4. Question 3. The equation of the tangent to the graph at x equals -1 is y equals 6x plus 7. Right, so x equals -1. Right, if we were to draw a tangent there, something like this, it will be a straight line with a gradient of 6. So remember, this is a linear graph, so y equals mx plus c. The gradient is 6, and the y-intercept is 7. So if we can't see it on the graph, it's somewhere up there, it will cross the y-axis. Okay, and then it says find the equation of the tangent to the graph x equals 1, which is over here. So we need to recognize that this is symmetrical. This is a symmetrical graph. So the line we over here is going to be very similar to that one. Just where this one is positive, this one is going to be negative. So that's the first thing, right? It's got a strong relationship to this graph, to the equation of the tangent of the other one. First of all, we know at the top, because it's symmetrical, it will cross at the same point. So that will be plus 7. We need to write an equation, so we need to put y equals, we need to put the x, and then we just need to think of the gradient. Okay, very simple. This is a positive gradient. This one is similar gradient, only it goes the other way, it means it's negative. That will give us -6 as the gradient. Question 6b, we complete the table. That is very quick to do on your calculator if you press the right buttons. Let's see, our equation is 1 plus fraction 5 over 3 minus, and the first value we want to put in there is a -1. It's always safe to use brackets, equals, and we got the first value 2.25. Okay, make sure you write this to 3 significant figures at least. Next value we need to put in there 0. Let's go back with the arrows, change the -1 to 0, and we have 2.6 recurring. Okay, 3 significant figures, 2.67. And the last one, we need to put in 1, change the 0 for a 1. We got 3.5. Okay, then on the grid, draw the graph. Let's do that. So make sure you plot these points very accurately. Remember, we need to go along the corridor up the stairs. So x minus 2, 2 will be over there. Minus 1.5, 2.1. Each little square is 1. 2. Negative 0.5, 2.43. 1.5, 4.33. Once you plotted the points accurately, do not use a ruler to connect them. Connect them by freehand. And done. Write down the values of x where the two graphs intercept. There's the first one. We go down there. Okay. Minus 1 is there. Negative 0.5. So it's in between those two. Mine would be exactly halfway. Mine. So that's minus 0.75. And the other value over here. So this is 0.5. That would be 0.6. So minus 0.55 roughly. On the mark scheme here, in case you haven't got the mark scheme, your values for the first one could be anything between minus 0.78 to minus 0.72, and for the second value here, anything between 0.55 to 0.59. Question 6C number 2. Now in the examiner's report they said this question was not attempted by many candidates, and I can understand why. It is a bit confusing. The answers to part C1 are two solutions of a cubic equation. Okay, what we need to recognize here is the cubic equation's got three solutions and we've only got two. Let me show you exactly what that means. So here we have the first graph they've given us in red. Then if we draw over that, the second graph we had to find the points for and just plot it. That's the one in blue. And the two solutions we found here is where these two intersect. But what we don't see on our graph, if we zoom out, there is another part to the graph we just plotted. That's over there. And this graph will cross again down here. Okay. Hence meaning we've got 3 points intersecting. Now if we connect these 3 points with a graph, it will form a cubic graph, and that cubic graph will have an equation. If I were to show you the answer quickly, it will look like this. Okay, which is crazy. Can't really see that clearly, but that is a cubic graph because it goes up, make a curve, comes down, make a curve. All right, and that's what we need to find. That answer there, the graph that goes through all 3 points where these two graphs intercept. Okay, now what we need to remember is where graphs intercept, that is where they are equal to each other. So getting back to our question, what we need to do here to find those 3 points, we need to set the two equations that we have. The first one we found was y equals 4 minus 3x squared, and the second equation they gave us, y equals 1 plus 5 over 3 minus x. Where these graphs intersect, they will be equal to each other, meaning we can set them as equal to each other. So that means 1 plus 5, 3 minus x, they will have the same y value. So they are the same. And we have to solve this. Okay. Right, so where to start? First, I need to get rid of any fractions. Okay, now the logical thing would be to take the 3 minus x and multiply it on the other side, but that 1 there is in the way. So first, we're going to subtract 1 from both sides. That will give us 5 over 3 minus x equals 3 minus 3x squared. Okay, then we can multiply the 3 minus x. So that goes 5 equals 3 minus x, 3 minus 3x squared. Okay, let's multiply out these brackets. That will be 5 equals 3 times 3 is 9. 3 times minus 3x is minus 9x squared. Then minus x times 3 is minus 3x. And minus x times minus 3x will give me a positive 3x cubed. Okay, we need to set all of this equal to 0, which means we move the 5 across. We move the 5 across, it will be minus 5. We can just subtract 5 from both sides, which will give us a final answer if we write it in the correct order and we don't make silly mistakes like that one, which needs to be cubed. So writing this in the right order, I've got 3x cubed minus 9x squared minus 3x, and 9 minus 5 is plus 4 equal to 0. So question 7, box and whisper plots, my favorite. The first one says to find the median mark. The median, of course, is the line that's in the middle of the box. That's straightforward, 70. Working out the range, don't confuse this with the interquartile range. This is just a straightforward range, the biggest value here being 90 and the smallest minimum value being 12, not 11, which will give us a sweet 78. Okay, then Jais scored a mark in the test that was higher than the mark scored by 75% of the students. Write down a possible mark for Jais. So there's more than one correct answer here, but what they want you to recognize is that the lower quartile counts for 25%. Then just below the median, that's another 25%. Between the upper quartile and the median is another 25%. And then the top 25% would be above the upper quartile. So any value that falls in this bracket here, which is from 86 to 90, so you can write down any possible value, 87, 88, 89. She could be the top student scoring 90. I'm going to go for the safe 89. That's a sweet answer. Okay. Then question 4 wants us to make a comparison between the distributions of the marks of the two tests. The important thing here, this is maths, use numbers. Okay, the most straightforward answer here would be to compare the median. The median of the first one is 70. The median of the second test was 74. So a good answer here would be to say, on average, the students scored better in the second test because the median is 74 in the second test compared to 70 in the first one. So there's my answer. Important, I mentioned the numbers, the values, and explain what it meant. You can compare other facets of the diagram, like the interquartile range, and say in general there was more consistent in the second test because the interquartile range is smaller. As long as you mention the actual values, the interquartile range of the second one is 20 compared to the interquartile range of the first one, which is, what is that, 58? 86 minus 53, which is bigger. Okay, use numbers and explain them, and you'll get your mark. Question 7b, it shows us a grouped frequency table, and they want us to calculate the mean. All right, remember, to calculate the mean, we need to add up all the values and divide them by the number there is. In this case, in a group frequency table, we have a slight problem. We know that there was the plants, we're talking about plants, yeah, there was 4 plants with a height between 0 and 20, but we don't know the exact height of these plants, which means we're not going to work out an exact answer, we're going to work out an estimate. Okay, so these 4 plants, we can have an estimate. On average, we'd say they would be around 10 centimeters high. So we take the midpoint. Okay, so if I got 10 plants, that's on average 4 plants, that's on average 10 centimeters high. We add their heights together, that will be 40, or 4 times 10. And we continue this pattern. To add that, we have to add the height of these 9 plants. We take the midpoint of the group. So on average, these 9 plants were 25 centimeters high. So that will be 9 times 25. Next one, there were 20 plants, and halfway between 30 and 34 is 32. So on average, they were 32 centimeters high. Next one, 15 plants, and the midpoint there being, what's that, 36, no, 37. If you're not sure about the midpoint, all you can do is you add together the 2 values and divide it by 2, 37. So you be certain. Well, this is one of the main points students lose marks. They get the wrong midpoint. Okay, once we have all the heights of all the plants added together, we need to divide it by the number of values. In this case, it is the number of plants. Okay, to do that, we can add up this frequency column and find the total, but they actually already gave it to us. It's over there. So we divide this by 50. And now it's just putting it into the calculator and getting the answer. So here we go. Right, so once we put in the values into our calculator, we'll get an answer. Now it's very easy to make a mistake here, to press the wrong button at the wrong time. I've got the answer 1128.1. Does that make sense? Let's see. Is there any of my plants that was that tall? No. None of my plants 1128.1 centimeters high. That must be wrong. We expect something in the middle, around 30, between 30 and 34. So let's go back and see if I can find my mistake. And we go back, and there it is. Instead of my last value, instead of putting a plus, I put a times. We put the plus, and we got a new answer, 31.2. 31.2 makes more sense because it is somewhere in the middle here. So that seems like a very plausible answer. So I probably got this one right. Okay, it does help to do this calculation more than once to double check, because as I said, it's easy to press the wrong buttons by mistake and lose marks for that. Okay, it's important here to show what you're working out. You'll get a mark for showing that you've used the midpoints. You'll get a mark for your method here, adding up, getting the total. You get a mark for dividing by 50, and then a mark for the correct answer. 7C, histograms. Histograms, remember the formula. The way I do that, I just remember that the area of the bar equals the frequency. So that means frequency equals frequency density times the bottom axis, which is the class width. Or even better, if you can do an old-fashioned triangle, right? That means frequency, abbreviated as FR, is the frequency density, that makes sense, times the class width. Let's make that CW. Class width being how wide our bars is. Okay, so in this case, my first bar here will have a class width of 10. The second one will have a class width of 5. That would be 10 and 15. Don't confuse this with the previous question where we had a similar frequency, group frequency table, and we use the midpoints to calculate the mean. Here we use class width. Right, so for question number 1, work out the value of x. We look at that. The value of x is the frequency. So to work it out, we need to take the frequency density times the class width. The class width we have 5. Frequency density, we're going to have to read from here, from the y-axis. Okay, it's the second bar there in our graph. So just look very carefully. This is 6, that is 8, so halfway would be 7. In between two values, we've got 5 squares, so we'll probably go up by 0.2. Let's just count if it makes sense. So this will be 7.2, 7.4, 7.6, 7.8, and 8. So yes, our frequency density for the second bar is 7.6. So to work out the frequency, we need to do frequency density 7.6 times the width of the bar, which is 5. So let's write that down. X will be 7.6 times 5. Okay, 38. Next question, complete the histogram. So we need to draw 2 more bars, and in the table it will be these 2. Okay, what we need to work out now is the frequency density. To get that, using our formula triangle on the left, to work out frequency density, we need to do frequency divided by class width. So for this one here, it will be 44 divided by 10. Let's write our working out in the right place down here. So 44 divided by 10 will give us 4.4. Drawing that in the bar. Okay, so remember, we need to go from 115 to 125, which is over there. 4.4. Each small square counts for 2, so 4.4 will be 2 squares above. And there we go, with a ruler and a pencil. Neat. Second bar over here. Frequency 51 divided by 15. So the second calculation is 51 divided by 15, which give us 3.4. Okay, double check that. Okay, so 3.4. Let's have a look. There is 3, 2 squares, 3.4, 2 squares above that. So 1, 2. This will be a bar that takes us all the way home. And we have full marks. Question 8a. The diagram shows a sector OXY of a circle with a center 0 and a radius of 9.5 centimeter. Remember, always with radiuses stay the same. So it means if we got the y is 9.5 centimeters, OX would also be 9.5. Okay, the sector angle is 53 degrees. We're going to have to use that. A lies on OX and B lies on OA. OA equals OB. So here we have an isosceles triangle. Show that the area of the sector is 41.7 centimeters squared, correct to 1 decimal place. Remember, the sector is just part of a circle. That means to find the area, we're going to do pi r squared. But this is not a whole circle. This is a fraction of a circle. That fraction is the angle. So that means we multiply that by the angle divided by the whole circle, 360. So my calculation looks like this. Pi, radius is 9.5 squared times the angle, 53 over 360. Let's put that into a calculator. Equals Okay, very important here is to write the unrounded answer. Okay, put a bunch of decimal values there. Okay, etc. Because they've given us the answer, and then we just show that that answer we have rounds to 41.7. You lose a mark if you don't write the whole answer. Question 8a, the second part, slightly harder answer, a question. The area of the triangle OAB is a third of the area of sector OXY. Let's first use that piece of information. The area of the triangle is a third of the area we've just worked out. That means to get the area of the triangle, we need to do 41.7 divided by 3, or times a third. Okay, 41.7 divided by 3, and that is 13.9. So let's see what information we have. Let's go back up here. Right, we've got this triangle here, OAB. We want to find out the length of OA. Let's make that x, which we know is the same as OB. Okay, and we now have the area of that triangle, which was, what was it again? 13.9. We also have an angle there, 53 degrees, and it's an isosceles triangle, so we can work out these angles at the bottom if we need to. Okay, area of a triangle. What do we know about that? There are two formulas for the area of a triangle. There is area of a triangle is half base times height. Do we have the height of this triangle? No. Do we have the base? No. And there's another formula. We know it's half AB sin C. Now this might be more helpful. In this formula, which we're probably going to have to use, we have the area, which is 13.9, half, okay, sin C means sin the angle. So we're going to, in our triangle, we're going to make the angle. We make that C, so we make the two other sides A and B. So this will be little c. A and B will be these two sides, which we know is the same, and I've labeled them x. So we can make A and B x. X times x, sin, then the angle, that was 33. That was very helpful. Now we just need to solve this thing, and we will be sorted. Okay. First, let's get rid of that half, the fraction. To get rid of that half, we multiply both sides by 2. Then we get rid of the half. So we got what here? 13.9 times 2, 27.8. Rid of the half, x times x is x squared. And we got sin 53. Okay, let's get rid of the sin 53. Remember, this is x squared times sin 53, which means we're going to divide the sin 2053 on the opposite side. So this is 27.8 divide sin 53 equals x squared. Let's type that into our calculator. And we get quite a substantial answer there. Let's write it here. 34.809, etc. equals x squared. Almost there. Just get rid of the square. So we square root our previous answer. And that will give us the answer. So we put square root, press the answer button, and insert the previous answer into our calculator. Press the answer, and there we go. So we get x equals 5.8999, etc. Now, when you write the final answer on the line here, please don't round it incorrectly. Okay, if you want to round it, well, if you write the whole answer like that, you'll get your full marks on the line here. If you want to round it to 3 significant figures, make sure you remember you cut it off there. After 89 comes 90. Question 8b. They give us a sector and they give us a cone, and they want us to work out the volume of the cone. Right, so first let us look carefully at all the information. This sector is formed into a cone. We got a radius of OP 24 centimeters. Now when we fold this into a cone, this radius 24 will become the slant height over here of the cone. As you can see, they've kept the labeling, so OP stays OP, that's 24 centimeters. All right, then PQ, you see they come together over here. So the arc length PQ will form the circumference of the base of the cone there. So this length is the same as the circumference there. Right. Any other information? Note that this 60-degree angle does not equate to the 60-degree angle there at the top of the cone, as it changes as we fold it. Right. So to work out the volume, we have the formula here. Let's write it down. So V equals 1/3 pi r squared h. So what do we need? Right, divided with the radius of this cone, meaning if I were to there, we need this value here, r. How can we possibly find that? Let's look at the information we have. From this sector here at the top, we can work out the length of PQ. When we have the length of the PQ, we have the circumference of the circle. When we have the circumference of the circle, we can work out the radius. It looks like this, right? To work out PQ, which is the arc length, we need to use the formula for the circumference of a circle 2 pi r, and then times it by the fraction of a circle we have. In this case, we only got 60 degrees out of 360. So that's 60 degrees times 360. That will give us PQ, which is the circumference of the circle. So let's do that. What was the radius? 24 times 60 over 360. Right, that gives us an answer of 25.1327. We can write it down like this, lots of decimal spaces, or to keep our answer more accurate, we write it as 8 pi. Okay, this will just keep our answer accurate. If we round the answer now, we'll lose marks later on and find that answer for not being accurate enough. Right, so now what we have here, we have the circumference of the base of the cone. Okay, using that, we can work out the radius. So let's think again, right? The circumference of a circle equals 2 pi r. Okay, we have the circumference in this case, it's 8 pi. So to find the radius, we need to divide it. So it's 8 pi divided by 2 pi. I still have that 8 pi in my calculator, divided by 2 pi. And yes, the radius equals to 4. Excellent. So now we got the radius. In our formula here, we can put 1/3 pi 4 squared. Next thing we need is the height h. Right, now remember this is the perpendicular height of the cone h. What do we have there? We got a right angle triangle, and we got two sides. We got the hypotenuse is 24, and we got the base of that triangle being 4. So yes, we're going to use Pythagoras. Okay, Pythagoras, don't confuse this h here with the hypotenuse. 24 is the hypotenuse. That means we'll have 24 squared equals, oh my goodness, 4 squared plus h squared. If we rearrange that, we'll get the height squared equals 24 squared minus 4 squared. And to speed things up, we can square root it straight away. So to get the height, let's do that. Square root 24 squared minus 4 squared equals, again, we can write 23.66431913, or more accurate, shorter version, 4 square root 35. That's the height. So we can now put it over here into our formula. So last thing left to do is to calculate the whole thing. So put it into our calculator exactly like it's there. Got 1/3 by 4 squared bracket 4 square root 35, close the bracket. And I've got a syntax error. Let's try again. There we go. 396.499, etc. That is now the most possible accurate answer. If we're going to round it to 3 significant figures, we round it to after the 6. So final answer 396. 9, factorization. Let's start with the first one there. 5a plus 10ap minus bm plus 2bp. Let's break this down into two parts. In the first two terms there, can you please write them? Please write for me. In the first two terms, we got a common factor of 5 and a. So we take out 5a from that first term, we're left with an m. We take out 5a from there, we're left with 2p. Double check. 5a times m, 5am, 5a times 2p is 10ap. Good. In the second part there, what do we have in common? We got a b. So factorize out the b, we're left with a negative m and a negative 2p. What do we put in front of the b? Okay, it's a positive b, we put a plus. Okay, now looking at this, it looks like we're close to something, but we're not quite there. We got an m plus 2p there and a negative m minus negative 2p. We can make them the same by factoring out that negative. Think of it as a negative 1. So I'm going to write all this again so it doesn't disappear. And we factorize a negative 1. That will make me negative 1b. Don't have to put the 1. And we now have m plus 2p. Okay, just double check. If we multiply out that bracket, minus b times m plus 2p, do we get minus bm minus 2bp? Yes, we do. All right, so now we got two terms, and in those two terms, we got two parts in the brackets that is the same. So we can factorize out that part there. So we can factorize out m plus 2p. In the first term, we'll be left with 5a. And factorize m plus 2p in the second term, we'll be left with minus b. And that is our final correct answer. M plus 2p, 5a minus b. If you got the brackets in the opposite way around, that's also correct. Question 9, number 2. Let's have a look. What can we see there? First, common factor of 15 and 20 is 5. So we can factorize out 5. We'll be left with 3k plus g squared minus 4k plus g, close the bracket. Okay, what else does these two terms have in common? We got an k plus g squared, so we've got it twice, and a k plus g, and we can factorize that out as well and put it in front with a 5. So it would look like this: 5k plus g, close bracket. That's all in front. Here we're left with 3k plus g minus 4. Right, we're almost there. Just for thoroughness, let's expand that one bracket. So that gives us k plus g, 3k plus 3g minus 4. Okay, and that's what they want. Final answer. Okay, so the straightforward brackets to expand, do that. The rest needs to be factorized. Okay, 5 k plus g, 3k plus 3g minus 4. Okay, last question. It looks like there is nothing to factorize here because there's no common terms between 4x squared and minus y to the power of 4. But what we need to recognize here is this is a complete square. We got two square numbers and a negative in the middle, which means we can make two brackets. Okay, if you can recognize this and see it, great. If not, I'll give an extra explanation after I finish this question. Hang around for that. Okay, so that means the square root of 2x squared is 2x. Square root of y to the power of 4 is y squared. And we put the same in both brackets with a plus and a minus. That's it. Quick and easy. Why can we do that? All right, let me explain this in more detail. Let's use an easier example. Let's use the example of x squared minus 4. Okay, x squared minus 4. Again, we got x squared is a square number, minus 4 is a square number. That will factorize to the square root of x is x, the square root of 4 is 2, put a plus and a minus. Okay, if we were to expand these brackets, x plus 2, x minus 2, we obviously have to get the answer above it, x squared minus 4. Let's see if that is the case. X times x is x squared, x times minus 2 is minus 2x, 2 times x is 2x, and 2 times minus 2 is minus 4. Now we'll have the x squared there, minus 2x plus 2x, they will eliminate each other, that will be 0, and we'll get the original answer. See, that works. Okay, that only works if we have a negative in the middle and we got two square numbers. Because we multiply the first term when expanding brackets with the first term, we get x squared, and we multiply the last term with the last term, that's term squared, and the positive and the negative makes a negative. And because we got a positive and a negative, they will eliminate each other, minus 2x plus 2x, and the middle term in the quadratic equation will fall away. All right, but it only works if you have a square number, and a negative. So that's what you need to look for. Question 9b, we've done factorization, now we do expanding, the opposite. First one is a cubic graph, expanding cubic equation. So expand and simplify x minus 3, x plus 1, 3x minus 4. There are different ways to do this. I'm just going to do it slowly and thoroughly as possible to make sure we don't make any mistakes. So I'm going to multiply, expand the first two brackets. So we start with x times x is x squared. X times 1 is plus 1x. Minus 3 times x is minus 3x. And minus 3 times 1 is minus 3. At the back, still hanging around, we got 3x minus 4. Don't lose it. All right, let's just simplify that bracket. So the x squared stays the same. X minus 3x will give us minus 2x. And there's a negative 3. Right, now we got two brackets to expand again. The first one got 3 terms and the second one 2 terms. Remember, we have to multiply everything with everything. So keep your head together. First, we're going to do x squared times 3x gives us 3x cubed. Then the x squared with the minus 4 will give us minus 4x squared. Next, we're going to do the middle term, the minus 2x. So the minus 2x times 3x will give us a negative 6x squared, and the negative 2x times the minus 4 gives us positive 8x. Look carefully at the signs to get them right. Last one, the negative 3. Negative 3 times 3x will give me negative 9x, and negative 3 times negative 4 gives me positive 12. All that's left to do now is simplify this. So 3x cubed minus 4x squared minus 6x. This is a simple subtraction that will give you a negative 10x squared. Remember, in this case, two negatives doesn't make a positive. We're just going down the number line. 8x minus 9x gives you negative 1x plus 12. And that is the correct final answer. 3x squared minus 10x squared. Now you see, you copy the answer wrong and you lose a mark for no reason. Double check. 3x cubed minus 10x squared minus x plus 12. Question C is not as hard as it looks. We got x plus a squared equals x squared plus 22x plus b. So remember that x plus a squared means x plus a times x plus a. Now what we need to remember here is when we expand the double bracket like x plus a, the middle term, in this case 22x, is the two last terms, a and a added together, and the last term, the b, is them multiplied together. Let's have a straightforward, easy example. Let's make a guess. Let's say a is 5. So we got x plus 5 and x plus 5. All right, this is just a guess. If we were to expand this bracket, we'll get x squared plus 5x plus 5x plus 25. Okay, those two middle terms add up to give us, in this case, 10x. And they multiply together gives 25. So 10x. What do we have here? 22x. What do we get add together to get 22? And it's the same number because it's both a. You got it. It will be 11. That means a must be 11. Now, if we were to expand these brackets, we will multiply the two 11s together to get the final last term, which is b. 11 times 11, 121. We're back with question 10a. A box is a cuboid with a length of 45 centimeters with a width of 30 centimeters and height of 42 centimeters. The box is completely filled with sand. Calculate the density. They give us the formula. We got the mass. We just need to work out the volume of the box, and that's straightforward. To find the volume of a cuboid, we do length times width times height. 45 times 30 times 42. That will give us 56,700 centimeters cubed. And to find the density, we take the mass, 90.72 divided by 56,700 kilograms divided by centimeters cubed gives us kilograms per centimeters cubed. But that's where we need to look carefully. I've just worked out centimeters cubed. They want the answer in meters cubed. Means we need to change centimeters cubed to meters cubed. So if we were to change 56,700 centimeters to meters, we would normally divide it by 100. But the moment it becomes nonlinear, becomes volume, we now have centimeters cubed, and meters cubed means we need to divide it by 100 cubed. So we do 56,700 divided by 100 cubed, which gives us 0.0567 meters cubed. Okay, so that means actually, let me just correct this. Our calculation is 0.0567. Let's do that, 90.72. And then we get the final correct answer of 1,600 kilograms. Be very careful with the units. Make sure you use the right units. Question B. Bag contains 15,000 centimeters cubed of sand. Some of the sand is used to completely fill a hole in the shape of a cylinder. The hole is 30 centimeters deep and has a radius of 10. Okay, so a perfect cylinder in the ground, 30 centimeters high and a radius of 10. The volume of a cylinder, remember, just like any prism, we need to take the area of the cross section, which in this case is a circle, so it's pi r squared, and then multiply it by the height. So this will be pi times 10 squared times the height is 30. Slot that into our calculator. Okay, which gives us good 9424.777. Don't round the answer yet because we want it to be as accurate as possible. So we can also leave it as 3000 pi, which would be even more accurate. Okay, calculate the percentage of the sand used from the bag that is used. So we need to take the amount of sand that's in the hole divided by how many sand there is in total. And because it's percentage, we times it by 100. Okay. And there we go. That will give us 20 pi as a decimal value, which will be 62.831, etc. Round to three significant figures, 62.8. Question C. Sands cost $98.90 per ton. This cost includes a tax of 15%. Calculate the amount of tax paid per ton of sand. We need to recognize here that we're kind of working backwards, right? There was the original price of the sand. Let's call that the original price. Let's just write it as it is. Then we multiply this to get the actual price of the sand. We have to increase it. So remember, when we increase something by 15%, we take 15% of that amount and we add it to the original amount, which is 100%, and we end up with 115%, which is a decimal value is 1.15. That is our multiplier. That is what we multiply the original price by to get the final amount, 98.90. So now we're working backwards. To find the original price, we need to divide the 1.15. Okay, so the original price pre-tax of the sand is 98.90 divided by 1.15. $86. So that's what the sand is without the tax. Now the actual question is calculate the amount of tax paid per ton of sand. So the actual amount is 98.90 minus that 86, which is $12.90. That's the actual tax. Goes to the government. Question D. Raj buys some sand for 3,540 rupees. Calculate the cost in dollars when the exchange rate is $1 equals 70.80. Let's write it down. So $1 is 70.8 rupees. Okay, we can do this like a ratio. Well, we actually have 3,500 rupees. So the question is, how do we get from 17.8 to 3,540? What do we multiply by? So we do the inverse calculation. We divide it. Okay, 3,540 divided by 70.8. That gives us 50. That means in this ratio, we need to increase the dollars by 50, which is obviously $50. Okay, make sure you show you're working out there. You get a mark for doing 3540 divided by 70.8. Question 11. Gaia spends $48 to buy books at the cost of X dollars each. Write down an expression in terms of X for the number of books Gaia buys. Right, imagine we knew what X was. Imagine X was 4. So we want to know how many books she bought. If she spent $48, we would do $48 divided by 4. Answer, she bought 12 books. Now we need to do the same, just we don't know how many books it is. So we do 48 divided by X, whatever X is. You can write it like this, or you can write it as a fraction. Both answers is correct. Okay. Next question, Myra spent $60 to buy books that cost X plus $2 each. So what is Myra's amount of books she buys? Okay, same as the previous question. She spent $60. We divide that by how much each book cost, X plus 2. Her books is a bit more expensive than Gaia's. We'll find the amount of books Gaia buys. We have now dealt with that first piece of information. Gaia buys 4 more books than Myra. That means if we add 4 books to Myra's amount of books, we will have the amount that Gaia bought. We know how many Gaia bought because we worked that out in question A. She bought 48 over X. All right, what we need to recognize here is we are dealing with algebraic fractions. We're going to have to add these fractions together. So what I'm going to do, I'm going to get that 4 out of the way and just deal with the fraction that's X plus 2 and X as denominators. All right, so we are swapping the 4 and the other fraction around. So it's going to look like this. 60 over X plus 2, subtract the 48 over X equals, and I got that 4 out of the way. We're now adding 2 fractions together, and we need to get the denominators the same. Let's do a basic, quick, simple example here. If I were to add a half and let's say 2/3, will first, the long way, get those denominators the same. In this case, it will be 2 times 3 is 6. Then I'll have to do equivalent fractions, which means I'll have to multiply the 1 by 3 and the 2 by 2 to ensure that I keep similar fractions, and then I can add them together. Okay, we are now doing the same here. Okay, it's also called the smiley face method. We need to multiply these 2 denominators together to get a common factor. That will give us X times X plus 2. Okay, then because we multiply the X by 2 by X, we need to multiply the 60 by X as well. That will give us 60X. Then there's a minus in the middle, yeah? Don't forget that minus. And on the right hand side, because we multiply the X by X plus 2, we need to multiply the 48 by X plus 2 as well. And you need to multiply everything. So brackets are in order here. Okay, and remember, all of that is equal to -4. Okay, now we can start simplifying things. All right, the numerator there, we got 60X. 48 times X is minus 48X. And minus 48 times 2 is -96. I want to get rid of that X bracket X plus 2 as a numerator. So it means I'm going to multiply it on the other side. So that means the -4 gets multiplied by X and X plus 2. Right, let's see what we can do here. We can do 60X minus 48X, which gives us 12X. And in the right hand side, we can expand the brackets. Minus 4X times X is minus 4X squared. And minus 4 times 2 will give me minus 8X. Now, let's go back to what we're aiming for. We're aiming for X squared plus 5X minus 24. So I want to move everything to the left hand side to have it all equal to 0. So the minus 4X squared can be 4X squared. The minus 8X becomes plus 8X. There was already a 12X and a -96. Let's simplify that. The 4X squared stays the same. 8X plus 12X is 20X. Subtract 96. Okay. Do we have what we want? Not quite. Okay, I've got x squared plus 5x minus 24 equals 0. What we can do is here, we can divide everything by a common factor. Divide by 4. Remember, if we do the same on the left and right hand side of the equal sign, the equation stays the same. So 4x squared divided by 4 will give us 1x squared, or just x squared. 20x divided by 4 will give us 5x. And negative 96 divided by 4 will give us negative 24. And excellent. We've got what we wanted. X squared plus 5x minus 24 equals 0. Question C wants now for us to solve that equation, and they are very specific. They want us to use factorization. Right. So factorization means for a quadratic equation, 2 brackets. We're going to have the x there and an x there. And because we got a negative 24, we know that one of these signs is going to have to be a negative, because as we multiply the last two terms, we need to get 24. So let's think of two numbers multiplied together that give us negative 24. What springs to mind is, for example, 4 and 6 gives us 24. One of them will have to be negative to get a negative 24. But then, when we multiply these brackets, the two middle terms need to give us a 5x, meaning if we add these together, we need to get a positive 5. When we add these two together, we get a positive 2. So we need to think of two other numbers multiplied together to give us negative 24. And what springs to mind here with me is 3 times 8 is 24. One of them needs to be negative. Let's say if the 8 is negative, adding them together will give me a negative 5. We want a positive. So let's swap that. Let's make the minus 3 negative and the 8 positive. That gives us negative 24, which we want there. And when we add the negative 3 and the 8 together, we get a positive 5, what we wanted there. So I got it. The negative 3 goes with the negative, the 8 is positive. Right, that's one way of factorizing them. What we need to solve it, we need to find out what is 0. Now, because these two together multiplied together gives me 0, it means each can be set as equal to 0. So if x plus 8 is 0, x is negative 8. If x minus 3 is equal to 0, it means x equals 3. So there's our two answers, negative 8 and 3. Question D, follow on from that. Then find the number of books Mira buys. Let's just go back. How many books did Mira buy? Mira spent $60 to buy books that cost x plus 2. So the number of books Mira was buying was this equation. 60 over x plus 2. Now we got two possible answers. And we knew she was buying books. She took books home. She didn't donate them. So we probably need to use the positive answer there, which means to work this out, it'll be 6. X will be 3 plus 2, which is 60 divided by 5, which gives us 12 books. Is what she bought. Question 12a. Find the gradient of a curve y equals 2x cubed minus 7x plus 4 cubic graph when x equals minus 2. Let's have a look at what that graph looks like. Of course, you won't be able to do this in the exam. There it is, cubic graph. Got two turning points. If we look at where x equals minus 2, it will be a point over here. And we need to find the gradient, which means if you were to draw a tangent to that graph there at x minus 2, not quite correct that tangent, we'll have to find the gradient of that line. Now, we don't have a graph to help us. We need to do this some other way, and the way to do that is through differentiation. So what will that be? Can you write for me, please? Thank you. All right, differentiation looks as follows. We need to multiply the power, the 3, with the 2. So 3 times 2 is 6, x, and subtract 1 from that 3. That gives us squared. Next one, imagine there's a little 1 power there, so 1 times minus 7 is minus 7. Then that 1 minus 1 is 0. So anything to the power of 0 equals 1. So we just got the minus 7. Okay, and remember the last full term falls away. You can imagine there being x to the power of 0. 0 times 4 is 0. 0 times anything is 0, so that falls away. Now we want to know what is the gradient at x equals minus 2. So we now substitute minus 2 in there. Minus 2 squared is 4. 4 times 6, 24. 24 minus 7 equals 17. And that will be the gradient, which is a very steep gradient. But as we looked before, it is a very steep line going up there. Question B, they want us to calculate the length between two coordinates. Again, let's have a look what that looks like. Two coordinates, there they are, minus 5, 8, 7, 2, and the length between those two would be the length of that line. Right, having coordinates, we need to work out the change in x and the change in y, meaning it will look like that. We've got a right angle triangle, and we now need to work out the distance between those, so meaning that distance, and then yes, you got it right. Right angle triangle, we use Pythagoras. Okay, so to find the length on the y-axis, we need to subtract the two x values, right? So that we can call this x, which is the first value x1 and that's x2. So the length of the line would be x2 minus x1, which in this case will be 7 minus 5, which will give us 12. All right, so that gives us the length here, 12. Then to find the change in y, we need to take the two y values. Let's call this y1, and that is y2. So we need to subtract the two y values. That's y2 minus y1, which in this case would have been 8 minus 2. That gives us 6. So now we have this length here of this right angle triangle. Then using Pythagoras to get the hypotenuse, we're going to have to do the square root of 6 squared plus 12 squared. So what it means over here, what we're actually doing after we've subtracted those, we need to square our answers and then add it together and find the square root of that. So as you can see, what I've done here, I've actually find the actual formula that you can learn to find the length of a line. Square root x squared minus x1 squared s. But if you can remember how it works in your head, you don't have to memorize the formula. We're just doing Pythagoras, finding the distance between the two x values and the two y values. Right, so what does that mean? That means we do the square root of 12 squared plus 6 squared, which will give me 13.416, rounded to three significant figures, 13.4. Question 2. Well, 12b, number 2, we need to find the equation of a line that's perpendicular to AB that passes through the point minus 1, 3, and write it in the form y equals mx plus c. So let's look at this again. This is the line they're referring to, the previous question, where they gave us the two coordinates. Now they tell us we have a line that goes through point minus 1, 3, which will be over there. And then if we draw from there a line going perpendicular, it goes through this point, perpendicular. So yeah, that's what we need, the equation of that line. Right, first is we're going to need the equation of our original line, the one between minus 5, 8, and 7, 2. From that, we can get the equation of the perpendicular line. So how will we find that? Formula, remember, gradient is the change in x over the change in y. And we have a formula for this one, right? To work out the gradient of a line, We get the change in y, which is y over 2 minus y over 1, and the change in x. I might have said it the wrong way around before. Can't remember now. So that doesn't mean we need to go back to our previous question to get that gradient there. We had these 2 points, and we call that x1 and y1, x2, y2. So we got 8 minus 2 again, like we did before. 8 minus 2. And for the x values, we're going to do minus 5, minus 7. Minus 5, minus 7. So 8 minus 2 is 6 over negative 12. If we simplify that, we get minus a half. Okay, let's check. Does that make sense? Right, yes, this is a negative gradient. For every 1 length we go to the left, we go half the value up. Right, now, perpendicular line means go to the 90-degree angle. What happens to the gradient? First of all, you'll notice the gradient changes from negative to positive, and also we invert it, where we used to go 2 squares to the side and 1 up, or 1 square to the side, 2, yeah? Now it's the opposite. So the gradient of our new line would be positive, and it would swap to 2 over 1. The 1 over 2 becomes 2 over 1, which gives a gradient of 2. So we can actually start writing our equation now. That's y equals 2x, remember, as the m value indicates the gradient. What we need to find now is the plus c. So we got y equals 2x. We need to find that. Well, we do have and y and an x value we can put into this equation. And that's why they gave us the point minus 1 and 3. That minus 1 is an x value, that 3 is y value. So we just substitute it into what we have of the equation. So that means we got 3, 2, the x is minus 1, plus c. 2 times minus 1 is minus 2. Add the 2 on the other side. We got the c value equals 5. That's what we put at the end. Brilliant. And we have the right answer. Question 12b, number 3, the last question on the paper. And this is the examiner's swan song, the one where they try to break you. But you can do it. If you just take each piece of information one at a time and go through this slowly, it is very doable. So let's start. AB is one side of a parallelogram ABCD. Remember this, AB refers to the AB coordinates, which is at the beginning of question B. We got 7, 2 and minus 5, 8. It's important to notice that A is 7, 2 and B is minus 5, 8. Now, reading the examiner's report, students who got this right, they all drew a diagram. Okay, here's my diagram to have things clear. So remember, A, let me just get this right. A is the point 7, 2, and B is the point minus 5, 8. Okay, so now that we got that clear, we've dealt with the first piece of information, which is the first line. So then we go on to the second part. BC with an arrow. So remember, this is a vector, and then they give us a column vector with minus A, minus B. Now, if you remember vectors correctly, the top number tells us how we moved left or right. So it means for BC, we're going to move to the left, and and then we're going to move down because it's negative. Negative means left, negative means down. Then they tell us A is bigger than 0, B is bigger than 0. This is just so that if A was negative, we would have had 2 negatives minus A, which would turn it positive. So this is just to make it very clear that BC is a vector that goes left and goes down. So let's see what that might look like on a diagram. Okay, so B is the point up here. So this is what it's telling us is that the side BC, so let's imagine C is a point over here somewhere, just as a wild guess. Okay, it means that we're moving to the left and we're moving down. Okay, It just means C cannot be above or to the right. C is to the left and below. That's all. That's what that piece of information tells us. Okay, so C over here somewhere. Okay, so we've dealt with this information. That's what we can get from it. The gradient of BC is 1. So what does that mean? Okay, let's look on the diagram. What does that mean? Gradient means the rise over the run. Okay, meaning how much we go to the side and how much we go up. It means the amount of we go to the right and up will be the same. So in this example, it will be 4 over 4. Okay, it could also be, of course, something else. It could be over there, which means it's 1 over 1. Or it could be over here, which means C is 2 over 2. That's what a gradient of 1 means. Okay, if the rise and the run is the same. That also actually tells us that A and B is the same value. Okay, which is confusing. Usually if they're the same value, they will give them the same letter. But in this case, it's not. We need to deduce that information ourselves. So now we know that A equals B and the gradient is 1. So, all right, we got that. Next one. BC equals square root 8. So that is the magnitude of the vector, the size, how big it is. Okay, so what does that mean? Let's have a look. Okay, that means that, okay, whatever C is, let's just guess for now, if you don't know what C is. If C is there, it means the length of this line is square root 8. And remember, because the gradient is 1, these two values are the same. A and B is the same. So let's call them both x, which is equal to A, which is equal to B. Okay, so now we recognize, what do we have? Yes, a right angle triangle working with a hypotenuse and the length of the sides means Pythagoras. Okay, and the great thing with this Pythagoras is also an isosceles triangle, so we've got two values the same. So now we can start writing some things down now that we've processed each piece of information very carefully. Okay, so we know that using Pythagoras, let's just go back there again quickly. Okay, square root 8 squared equals, we had this x squared plus x squared, Pythagoras. Okay, let's get rid of that square root on this side, or not. Square root squared just gives us 8. X squared plus x squared is 2x squared. Let's divide that 2 on both sides. So that gives us 4. That means x is the square root of 4, and we got it. X equals 2. Plus and minus 2, but we only work with positive values here. So excellent. Now we can change our drawing here now, as we know now that in fact this length is 2, that length is 2, so C lies over there. Okay, and the side of this parallelogram is there. Okay, so we've done it. We've got the coordinates of C. What do they want? They want the coordinates of D. So, meaning this being a parallelogram, A, B, C, D will be down here. Okay, meaning we need to go 2 squares down, 2 squares across, as in a parallelogram, opposite sides are parallel, which means they've got the same gradient. And there I've got the answer. D is the point 5, 0. Or rather, showing the calculation now, since we know x is 2, we know the coordinates of A is, what is that, 7, 2. We need to subtract 2 from each coordinate, which gives us 5 and 0. Give us the final answer, 5, 0. So not too difficult. If you draw a diagram and interpret each piece of information carefully, one at a time, you can do it. Well done. This is it for this extended paper. I hope you found this useful. Please like and subscribe. See you again soon.